Good morning, good afternoon, good evening. Welcome back to this public lecture on artificial intelligence in power system optimization. Of course, my name is Dr. Enoch Mrenga. I've given you the other parts of this topic, and today and now we look at part 3, which looks at some of the challenges and future trends when it comes to artificial intelligence in power systems. We make conclusions and call it a day or a public lecture. So we defined the three terms: artificial intelligence, power system, and power system optimization. We also looked at why we need optimization in power system and also the challenges of uh, traditional techniques of power system optimization with a solution becoming artificial intelligence. In part 2, we looked at the role of artificial intelligence in power system optimization. We look at some of the techniques and also some selected application that you can do for artificial intelligence. So we start with a case study. Of course, we have mentioned some of the applications in terms of real world use cases where artificial intelligence can predict electricity demand through load forecasting. It can detect and diagnose faults early, thereby avoiding costly blackouts when it comes to a power system, or loss of loads and loss of production when it comes to one typical application that I'll give you today, which is to do with a mining load and of course addition of renewable energy integration. When it comes to smart grid management, of course, artificial intelligence can help in the automation of control systems. It also plays a crucial role in integrating renewable energy and optimizing energy storage systems like batteries. So this application is typical. We have got a mining load. Of course, it can be copper mining, it can be diamond mining, it can be platinum mining, it can be underground, it can be an open pit or surface mining as it's popularly known. So if we consider a mining site, of course, which has got high energy usage and in a remote location. So the addition of renewable energy, it can be wind, it can be solar, brings about a lot of variability. And of course, this is attributed to the coming in of electrification in mining and mineral processing, where we have a lot of mobile mining equipment being um, electrified, either hybrid, if we look at the hybrid dump trucks from Hitachi, or if we look at the pure electric that is now undergoing a field trial at one of the copper mines in Zambia. So what we are saying is artificial intelligence can help to analyze historical data in the electricity demand, look at the weather patterns, and also operational schedules that we have if we take of a typical open pit mine. So using neural networks and reinforcement training, it can balance power between the grid, solar panels, and also battery systems, resulting in a more effective, efficient, and stable energy supply. So this is one typical example. Of course, you can have other examples that can be given for that. When we come to some of the possible challenges that are attributed to artificial intelligence, of course, despite its benefits, it comes with its own challenges. We have got the high computational requirements, data quality issues, cyber security risk, and integration barriers. So what we are saying is, even if we have got data, how available is it? What is the quality of this data that will enable us application of artificial intelligence for processing? Um, Cybersecurity concerns. how can our systems be safe, or how can we make it safe? And of course, integrating artificial intelligence into our existing systems to have a seamless addition uh, is not a very straightforward thing. So these are some of the possible challenges that will come with artificial intelligence. Of course, in the future, now and in the future, we expect that artificial intelligence will begin to dominate. We are moving towards artificial intelligence powered autonomous power grids, micromanagement, even having quantum computing in power optimization. When it comes to microgrid, of course, we have got traditional microgrids, and also we have got mining microgrid. So we can have artificial intelligence driven microgrid management. When it comes to a typical power systems, a utility company, one important topic is demand side management. So when it comes to demand side management, it's very important. So the application of artificial intelligence will become popular when it comes to demand side management for most of the power systems or power distribution systems. So what we can say is that, in summary, optimization is essential for the traditional and modern power systems. So we have had traditional optimization techniques that we have been used alone, they are not enough. So AI will come in as a solution that is needed for power system optimization. So it will provide the intelligence, adaptability, predictive power that we need to build smarter, more sustainable energy systems. Of course, there will be continued innovation and research that is key to continue. So if we look at the future, when it comes to smart energy networks and solutions, AI powered smart energy solution will yield or hold power. The application of artificial intelligence in power system optimization, of course, will give us the three key elements or areas that of improved efficiency, reliability, and sustainability for our power system. Thank you very much. Hope you have learned one or two things in this topic of artificial intelligence, AI, in power system optimization, PSO. Hope you have enjoyed it. It has ignited your interest. It is an area that you'd want to jump in and do research or find certain aspects. Thank you very much, and thank you for listening.